Hello everyone, today I'm going to show you how to manufacture the USB carrier bottom. It's relatively simple, so this should be easy. Alright, let's click out of design for our first thing to do. Go to manufacture. Let's create our first setup, which is needed for pretty much everything manufacturing. Make sure it's selected to the model, make sure the origin is center top stock, and add stock to all sides. We're going to want to add a little to the X to ensure a nicer finish, so just 0.1. Or actually, let's dumb that down, 0.05. So it's 4.1. And we want the stock depth and height to equal our stock size, which is 1 by 2. So stock depth is going to be 2, so it's going to be 0.125 for everything. And then the negative Z, we're going to go 0.2 to add a little more stock to the bottom that we're just going to face off later. And the plus is going to be 0.05. And there we go, 2 by 1. Go to post process, and the WCS offset is going to just change it to 1. That's okay. There we go. Relatively simple. All right, let's click on the facing operation, first operation in pretty much any program. Select the stock, select your tool, and 3-inch face mill floor flute. The spindle speed should be 5,000. And we're going to run this at a good 50 inches a minute. Let's change the ramp and plunge to 15. And that looks good. Geometry is already selected. Let's look at our heights here. Make sure everything is fine. All right, that looks good. For the passes, we do not need to change anything here. And it looks like we're all good. For this to load. And just like that, we have our first program thing. Let's simulate this. Right, everything looks good. Make sure it's not cutting off too much either. Yep, that looks good. And then the second thing we're going to do is a contour. So 2D contour. And that's just going to go around the edges. So we're not going to never contour with the face mill. Face mill is only for facing. Go here, go to Brian's tool library, 1/4 end mill right here. And we're going to change the feed rate. And here we're going to go 6,000 RPM. We're going to run it as fast as we can because we can. Let's change the feed rate to 40. Ramp and plunge, we can just do 20 for each. And that looks good. All right, then we're going to hop over to geometry. Since it's going to be going around the part, we're going to select this bottom chamfer edge. And that looks good. Let's go to our heights. Everything up here looks good, but we're going to go to bottom height, click off of selected contours, or actually we'll keep that. And we want it to go a little bit, like kind of towards the middle of the part, a little bit below. So -0.5 should be good. We'll see how that works when we actually click out, look at our passes. That looks fine. We're doing 3 axis, so we don't even check that. All right, and everything looks good. Let's plan this. Check the contour out. All right, that looks good. Should be no issue here. And the next thing we're going to do is do an adaptive for this pocket right here. So I'll go to 2D adaptive clearing, and it's already selected the 1/4 flat. And all of our feed rates look great, so just check these to make sure yours align with this. Pocket selection, this right here. Height, selected contours, that's good for an adaptive. I do not think we're gonna need stock to leave on. We'll check in a minute. All right, and then let's run this, simulate. All right, that looks great. Let's run through this again to make sure everything's all good. Optimal load. You can always go to edit expression. Cool diameter times 0.4. So it's using 40% of the tool, which is good for adaptives and stuff like that. And will make your life so much easier if you set that as your default. All right, now we're going to do the drilling and tapping for these holes right there. We did not model the tapping, but that does not matter. So we're going to go to drilling, drill. Never drill with an end mill. Change that to 0.1772, which is right here. To select all the holes. And for this, 5,000 RPM. And plunge feed rate 18 is fine. And everything should be good here. Check the heights, make sure that everything is fine. Okay, hole bottom, no offset, don't offset it. And make sure it's wrapped out. Drilling is funky sometimes, so just always double check your drilling. And that looks fine. Okay, exit the simulation. Go to your let's go to drilling again. And this time we're going to tap the holes we have already made with a, let's see, we're going to use 1030, 1030. Yeah, we can bump up the RPM. Let's go with that one. Check the heights, bottom height, bottom of the hole. Yeah, we don't need it to dwell. Oh, we must select our whole faces, of course. How could I forget that? This one, this one, this one, this one. Okay, that should work fine. Check that. All right, exit simulation. And we're going for the last part of the setup, we're going to chamfer all these edges. So 2D chamfer. And then we're not going to run this as fast as we did the other ones. So this and this. Go back to the feeds and speeds. Go 6,000 again. Cutting feed rate 25, not very fast. 15, 15. All right, that looks good. Go to geometry. Yep, just like we selected. Heights. Selected contour, so we're fine. Go to your passes. Chamfer clearance set as 0, but change the tip offset to 0.01. And then we can check linking real quick. All right, everything looks good. It's okay. Let's run this. Always make sure to have a chamfer tip offset or you will break the chamfer tool. All right, we can check where the tool is hitting with the we can tell it's not exactly hitting the line, so it won't break the chamfer tip. That's good. That's good. All right, exit simulation. Just like that, our first setup is done. All right, now moving on to the second setup. Just go to setup, flip this around. Before we do that, we might have to select a point. Select the bottom point of the piece. Here, 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 here. Flip this around. And yep, that looks good. Go to your stock. Great. WCS1. All right, now that we're done with that, we're going to face all of this excess material off. Only face with the face mill. There's no reason to face with anything else. So we can just go here, select the face mill again, face all of this off, and set everything like before. Do not run the face mill at 6,000. You will break something. Select multiple depth and the maximum step down 0.05. Don't set it high at all because that just produces more wear and tear, or it might just break the whole face mill entirely. All right, everything looks good. Press OK. And you can see with multiple step downs, it did several passes. Let's double check program. Exit simulation. Double check something real quick. That should be fine. All right. And then go to 2D. We're going to do the last chamfer or the last contour. We have to do a contour first. Go back to that trusty 1/4 end mill that we've been using this entire time. Select all of this. Go back to heights. Go down -0.5. And then change everything. 6,000, 40, 15, 15. Okay. Whoops, not again. Let's compare these two contours. Make sure we're not overlapping too much stock. All right, let's change this to 0.4. There. All right. And now that we've done that, 2D, where is it at? Chamfer, here it is. And we're just going to do the same thing. Select the chamfering tool, so 1/4, 6,000 RPM. Pretty slow. Let's run at 20. We're at feed rate 15, 15. No reason for it to be higher. Contour selection, bottom part of the chamfer, not the top. Heights, yep. Passes, no chamfer clearance because we modeled our chamfer. You may have to do that if you did not model the chamfer. Chamfer tip offset 0.01. Let's actually set that as the user default. Press OK. All right. And that should look fine. Let's run through both of these setups real quick. Simulate. All right, first setup looks good. Moving on. Second setup. Flip this around again. It should just face off everything. Contour, chamfer. All right. Seems good enough to me. Let's exit the simulation. And now that we have our bottom done, let's save it. All right. And we're going to go to our file. So go to here. And we're going to copy it. copy it into the same folder or wherever you're keeping it. Rename it, whoops, USB carrier T for top. Enter. All right, let's open this. And now that we've already done all of this, we can just go to the design. And we're going to extend this all the way through so that we can put pins in it. Like that. Okay. Looks great to me. Now we can go back to manufacture and it's going to show a whole bunch of errors, but that's okay. We can just go this here, there. All right. All right. All right. Delete the tap. We don't need it on this operation. There we go. Let's double check the program after we're done as well. That's going to set up, simulate. Doesn't seem like there's any errors so far. Speed things up a little bit. All right, amazing. Let's go to the second setup. Simulate this. Right, just the same as before. All right, awesome. Actually, let's go back to the drilling operation and make sure it's going all the way through. Home, front. Select this drilling operation. Holes. And then change the bottom height negative 0.1 maybe. Double check that, and that should go all the way through. But you don't want it to go all the way through the stock, just the model. Yeah, amazing. And let's check this second. I'm sure it's fine. We don't have to do that. And just like that, everything is done, and you can put them into the machine. Thank you.